Hi folks, we're going to take a look at number 3 from the homework. So here it says that Richie walked 15 meters diagonally across a rectangular field. Okay, so I'm going to draw a rectangular field. And it says that he walked diagonally, okay, across the field, and that was 15 meters. Okay, and then it says he returned to his starting position along the outside of the field, and the total distance walked was 36 meters. What are the dimensions of the field? Okay, so let me represent the whole path here. So started off by walking diagonally across, and then walked this way, and then finally back to his original position. And the total here is going to be 36. Okay, but what they're looking for is the dimensions of the field. Okay, so I'll give these names. I could call them length and width. I'll call them X and Y just to use something a little different here. All right, and what I know is that X plus Y plus 15, the whole path that he walked, is equal to 36. Okay, but this is an equation with two unknowns, so I can't solve for X and Y when I've got these two unknowns in that one equation. So that means I'm going to need a second equation. Okay, I'm going to solve a system. All right. Thing here is I need to find a second equation, and I hope that you realize that this path that I've created represents a right angle triangle. Okay, and anytime we have information or some kind of interest in all three sides of a right angle triangle, we should be thinking about Pythagoras. Had we had information about one of the angles, other than the 90 degree, we might think about using sine, cosine, or tangent. But here, since it's all three sides, I'm going to use Pythagoras to create a second equation. So here, this is the hypotenuse, so I can write x squared plus y squared equals 15 squared. And again, I have a second equation in the same two unknowns, x and y. All right, so this is where I can now either perform a substitution or an elimination. Now, especially because this equation here is not linear, in those circumstances, you're almost always going to use substitution. Okay, so if I look at this equation here, it's pretty easy to substitute. To isolate one of the variables. I'll choose to isolate y here. So what do we have? We have 36 minus 15. That's 21. Okay. And then here, bring the x to the other side, minus x. All right. So let's now put this into our other equation. So wherever cy, I'm going to replace it by 21 minus x. All right. And 15 squared is 225. And now, what have I created? I've created a quadratic equation, because when I expand this, I'm going to end up with x squareds. Okay. Now, again, I just want to mention here that there was no talk of optimization, so I know I'm not going to be completing the square here. I should have anticipated solving a quadratic equation. Okay, so even though we could probably figure this out, let's just do 21 squared. I'm going to need 21 squared in here. Okay, so 441. So let's now expand and bring everything to the left-hand side. So I've got my x squared here. So again, squaring a binomial, so squaring the first. 21 squared we just found was 441. Okay, twice the product of first and last, so 2 times 21 is 42. So it's going to be minus 42x. And then here, negative x times negative x is plus x squared. Okay, and I'll bring the 225 to the left side of the equation to get 0 there. Okay, so I just need to simplify. So here we have 2x squared. Here we've got minus 42x. And here 441 minus 225. Okay, 216. So this is going to be plus 216. Okay, now not that it's a necessary thing to do, because I could certainly apply the quadratic formula here, but I think it makes my life a little easier if I divide both sides of the equation by 2. So if I divide this polynomial by 2, I'm just going to be left with x squared minus 21x plus 108, and then 0 divided by 2 is still 0. Okay, now I could go straight into using the quadratic formula, but because I have an a value of 1 here, and these numbers are not so bad, I'm actually going to try to factor, especially since I look at 108, and I know that 9 times 12 is 108. And if I add together 9 and 12, I get exactly 21. Or in this case here, negative 9 and negative 12 add up to negative 21. So I'm actually going to solve this by factoring. Okay, had I done the quadratic formula, I would have gotten to the same answer if I did it correctly, but less chance of making errors here. So this can be factored as x minus 9 and x minus 12 equals 0. Okay, now here the coefficients are both 1, so I could just see that the answers are going to be 9 and 12. But just to get used to it, because sometimes people make mistakes when there are coefficients and they just take those numbers, which is incorrect, I'm actually going to write that here two things multiply to 0. So either x minus 9 is 0 or x minus 12 is 0, just to make sure that I don't make a mistake in other circumstances. So here x is either 9 or x is equal to 12. Okay, so we've got two possible values for x, so it could be that we just have two possible rectangles that will satisfy these conditions. Okay, so we want the dimensions. So the dimensions are length and width. So the length here for the first one would be x equals 9 meters, and then y is equal to 21. So now I can substitute this back into one of the equations. I might as well substitute it into the easier equation, 21 minus 9, and that's 12 meters. And I hope you see what's going to happen here, that if I take the second possibility, x equals 12, well, y is just 21 minus 12, which is equal to 9. So essentially, it's the same answer. It's just like having, 12 and 9 or 9 and 12. Both would work. So my answer is the dimensions are 12 meters by 9 meters. Whichever one is length and width is of no consequence to me. All right, so let's just do a quick recap. So step number 1, draw that diagram, okay? Because it might not be clear here in just reading the question that you're going to use Pythagoras. But once you draw it and you realize that you've got the diagonal of this rectangle and then the two sides, you can more easily see that you're dealing with a right angle triangle. And so if you need a second equation, you can use Pythagoras. Okay, and again, make sure you're doing your algebra very carefully, and recall that when you've got an easy quadratic, you can, of course, solve by factoring a little faster than using the quadratic formula. Okay, that's it for this one.